Gravitational field strength calculations. Right, so firstly, a gravitational field. So a gravitational field is a region of space surrounding a body in which another body experiences a force of gravitational attraction. So any planet or celestial body will have a specific mass, and that mass will determine how much the planet will attract other objects of mass towards it. To calculate this, we use the equation where weight is equal to the mass times gravitational field strength. Right, now, weight we measure in newtons. Mass we measure in kilograms, kg, and gravitational field strength, as mentioned here, is measured in newtons per kilogram. So on Earth, it is 9.8 newtons per kilogram that any object will experience. All that this means is that if we have a 1 kilogram object, it will be pulled down to Earth with a force of 9.8 newtons. Okay, and that is why we say 9.8 newtons per kilogram, and that's how we get to that. Now, the moon is far smaller than Earth, and so it only experiences a gravitational field strength of 1.66 newtons per kilogram. And so that same 1 kilogram object on the moon then will be pulled down with a force equivalent to 1.66 newtons. Okay, and that's why we see astronauts sort of float a lot when they bounce across the moon's surface, because they're not being pulled down by the same force that we're pulling down on Earth. Okay, and if we look at the definition then, the force, the gravitational field strength, is the force experienced by a mass of 1 kilogram in a particular gravitational field. On Earth, that gravitational field is 9.8 newtons per kilogram, and the moon is 1.66 newtons per kilogram. Okay, so let's look how do we do these calculations. Now, let's start with this Easter egg. So this Easter egg is on Earth, meaning that it'll experience a gravitational field strength of 9.8 newtons per kilogram, and it is being or has a mass of 50 grams. Now we cannot use 50 grams, we need to use kilograms, and so to convert grams to kilograms, we're going to divide by 1,000 because there are 1,000 grams in the kilogram. That means that in kilograms, this will be 0.05 kilograms. So to do the calculation, just get our calculator open so long. That is then going to be, as we do this calculation, move to the side. We're going to then experience Fg is equal to mass times gravitational field strength, and so weight is equal to the mass. Remember, always substitute this in kilograms times gravitational field strength of Earth of 9.8, and so 0.05 times 9.8 is equal to 0.49 newtons. Right, so the Easter egg has a weight of 0.49 newtons. Its mass, though, still remains 50 grams, or it's calculated 0.05 kilograms. Okay. A person, let's say we've got a person of mass of 70 kilograms. So to work out their weight on Earth, that's Fg, or weight, is equal to their mass times gravitational field strength on Earth. So that then is going to be 70 times 9.8, and we do the calculation. 70 times 9.8 is equal to 686 newtons. Now, if this same person went onto Mars, or onto the moon, on the moon, we'd then calculate it as Fg on the moon is equal to mass of the person, which remains the same everywhere, times gravitational field strength on the moon. And so that'll be 70 times 1.66 newtons per kilogram. And so the weight on the moon then would be 70 times 1.66. Right, so only 106.2 newtons. And so their weight is now almost 1/6 of their weight on the moon as it would be on Earth. Okay,